So welcome to my channel, guys. So this is the third part of our DOL starter. So in my first part I had explained you about what is a DOL starter, what are the components of a DOL starter. In the second part I explained you the power circuit of DOL starter. Now this is the third video where I'll be explaining you on the control circuit, and in my fourth video I will explain you how the power circuit is connected to the motor. So let's not waste your time and let's start. So guys, as I told you, the control circuit is used to control the motor power supply. Okay, power supply is provided by the power circuit, but it is controlled by the control circuit. So what's there? So if you see, so let me, okay, first you should understand that the voltage for a control circuit can be 450, 24 volt DC or 230 volt AC. Normally, see, I'll tell you, where you want a cheaper dual starter, people prefer 415, but for operational wise it's not safe for the person working. He should have a proper electrical knowledge to work in 415, but they can be used. It's not that they cannot be used, they can be used, but you have to be extra safety. For industrial standards, what we use normally is 24 volt DC. This is safe because the person who is working can safely work, do rewiring, remove the wiring, do the testing. It's safer part. So most probably people use 24 volt DC. And if you compare the which voltage is preferred, is 24 volt DC is first, then the 230, and then 450. So let me explain you each part. So if you can see here, the power, see, please remember that always when you connect, see, let me just explain you first fully. If you connect this wire to here directly without including the coil, it's a dead short. So whenever you are designing a power circuit, you should see that the current will enter to your neutral, that is here. It should come always after the coil. If you do not, you bypass the coil, and if you connect it, it's a dead short. So always remember this safety factor to be considered while you do the wiring. So let's come here. So the first part here, the power comes from here. First component connected is the fuse or MCB. You can use fuse or MCB based on your budget, so you can select. Mostly people use MCB because if it gets stripped, you have some problem shorting at the control circuit. The MCB gets stripped, then you can find the fault and replace it easily. But if your fuse blown off, then again you have to find a new fuse and then replace it. Takes time. So now the power is coming from here through the fuse. The first component what you encounter is the emergency. The emergency should be always located after the MCB. Why? Because see, from here is your, if you are having any fault or testing or you have to do anything, you start from this point. Once the fuse, so you can isolate it by removing the fuse. You can isolate and check all the components. So emergency, purpose of emergency is to stop the power to the motor. So when you press emergency, if you see, emergency is always NC. NC means normally closed. See, always you have to refer this as non-energized section. When there is no power, what will be state of this contact? That is always defined. Like NC is normally closed. So if there is no power or anything, it normally is closed. So the power comes from here, from the normally closed. Then is your push button. See, push button, you use NC, so that the power is coming from here, it goes to the NC and comes here. Now OLR comes. OLR, you know, that I had been saying that it also is a part which connects power circuit and control circuit. The OLR will change its contact from NC to NO if the motor current exceeds, and this will open, and the power which is coming from here, it stops here. So let me explain this. When emergency is pressed, the power is coming from here, it gets stopped here because NC will become NO and the power is cut to the circuit. Similarly, when the push button is not pressed, the power is there. When if it is pressed, the power get cut. Okay, so then afterwards the power has come from here, now it is here. One thing you should understand, this is the coil of the contactor. Now your voltage selection, like you are selecting here 230, the coil rating should be 230. If you are using 24, the coil should be 24. If you are using 415, the voltage should be, coil voltage should be 415. So when you give a power comes from NC, it will check NC is closed, okay, power will come to the next phase. The push button is not pressed, okay, power will come to the next one. The motor is not tripped, so OLR is healthy, the power will come here, and the power comes here and it is always available till here. Now what happens is, this is NO. The power comes here. When you press the start button, what happens is the power is coming from here to here, it goes here and it comes here. Now the coil gets the power. What will happen? It will close the contactor, and when it closes the contactor, in my previous video you have seen that the power to the motor goes. Now what happens? You cannot continuously keep pressing the start button, you leave your hand. But what will happen is, since the coil is having the power, this NO will become NC and power starts flowing from here and it sustains the power to this coil. Okay, now your motor is running. So what happens is, suddenly you want to stop the motor. So either you press the stop button or you press the emergency. What will happen? The power is cut. When the power is cut, the coil is not getting the power, the contactor opens, everything comes return back to the normal condition. Now if now this is what the starter circuit, and this is the indication lamp circuit. So indication lamp circuit, I will tell you. Now you know that the power is coming here, the coil is getting power, this NO will become NC. Now this is the same contact. Similarly, you have to use another, you should not use the same, but the coil is same. So this NO will become NC, power comes from here and the light on. So the motor is on, indication is on. But what will happen? NC will become NO and the off power is getting cut and off. This is off indication lamp, off is on, and this is trip indication. Now if when there is any problem, this OLR trips, so this NC will become NO, power is cut. The power is cut, what happens is, this NO, it happens reverse. NO usually turns into NC, NC into NO. So this will get into NC and you will get a trip indication. And again, see, lamps are used only for 230 and 24 volts. They are not used with 415. People don't prefer it because it will not even stand. So usually commonly used is 230 and 24. Thank you guys. Next in my next video I will be showing you how to connect a motor to the power circuit, and in this video also, if you have any doubts, you can just comment me, I will try to answer. Thank you guys.